जब ज्वाइन कर लो मैं लिंक दे पुरानी लिंक है ना उसी से ज्वाइन कर सकते हो तेरे पास पुरानी वाली क्या नहीं यार में स्टार्ट सेशन my slide is visible hello can anyone
Yes, it's visible.
okay let's discuss so the multiplicity of the HH plane in the cubic system what will be the answer 48 24 16 or 8 family of planes do you have any idea about this now we can calculate the multiplicity answer will be 24, but how? Can I discuss?
Yes, sir.
So let me give hint. First you have to try, then I will discuss. So generally, let's say HL, HHL. So choose just like parameter 1 or something, maybe like that. H, H or L. Two are same, one are different. We can choose like that. So let me take in variable form. How many combination of this? H and H and one L H H. This is three. Similarly, we can take minus H L. How many combination? Please write. Combination double. Please do the exercise like that. Arrange. So we can arrange similarly here. First page. So we can bar and so this type of how many? Three. And three are different. So we can apply permutation directly. P3 equal to 3 factorial. Six combination will be this is three. These are same. One, two, three. So how many? There will be only three. H, L, H, H, H. Others may be same. How many here? Three are different. So three permutation. Six, three, three. So please tell me. And one more. H, H, N. All are 92. Three, yeah. So 24. Whole sum. Can you arrange like that? Are you interested? So we can arrange plans like that. So this is the 24 combination. So multiplicity is 24. Clear? Can I move forward?
Sir, if it would have been HKL plane,
Then would it have been 48?
Yeah, HKL. So generally, sir, already as discussed, HKL 48, HHL 24, HKG 24. Are you able to see?
Yes, sir.
So just like we can arrange, sir, already discussed class. I think it's clear. Question: which of the following is are true for Miller indices? Crystallographic plane and direction. Plane and direction. First option, or the parallel distance plane must have different Miller indices. A plane parallel to one of the coordinate axis has an intercept of infinity of that axis. If the Miller indices of two planes the centers, the planes are parallel to each other, all the plane and direction in the cubic system are orthogonal to each other. So what will be the answer?
Sir, I think D and B.
Okay. So why not A? Why not C?
Sir, in the class, D sir said that they for a cubic system, the planes and the directions are orthogonal to each other.
Check.
And another case, and he's also while mentioning about the Miller indices of planes, he said that we should take the intercepts to infinity while carrying out the notations.
So but I'm asking why is A and C are not true?
In A, if they are equidistant, then they should have multiples of that plane.
So
For
it means
example, 1, 1, 1, then it will be 2, 2, 2, something.
Miller indices must have different.
No, sir, same. They would have been same.
So let's discuss first. Let's say our intercept 1, 1, 1, x axis x y z, and another case 1/2, 1/2, 1/2. Or you can generally take so equidistance. We have to take equidistance. So 2, 2, 2, 3, 3, 3. They are equidistance planes. So this is the intercept. Convert into Miller indices. Take reciprocal 1/2, 1/2. This is another case. This is this. Convert into integer 1, 1, 1. Multiply by 2, then 1, 1, 1, and 1, 1, 1. These are the same Miller indices. Of parallel plane set of planes which are equidistant. So must have different. This is the same. So this is not true. Clear? We can draw our plane. So you can find. So same B is a parallel plane to one of the coordinate axis has an intercept of the infinity on the axis. Let's say draw take this is plane. What will be the Miller indices of this? X, Y, and Z. This is the origin. So what will be this plane Miller indices? Can you tell me? Hello,
100.
100. Why 100? Because on x-axis this plane intercept here 1. Let's say unit is 1, and parallel to the z-axis and also y-axis. So assume this will be cut at infinity. So intercept 1, infinity, infinity. If you convert in Miller indices, 100. So assume plane are parallel, then they will cut each other to infinity. If the Miller indices of two planes are 1 to 1 and 2 for 4 of the planes are parallel to each other, so can you draw this plane? 1 to 1 Miller indices. Please convert into and intercept. First convert into intercept. Two, one, one. 2, 1, 1. Intercept is 2, 1, 1. How can you draw? This is the outside from the box.
So we can consider 1 half and 1.
Okay. So let me solve another way. We can, if parallel planes are multiples, generally here you can see here 2 times or 3 times. So this is not the case. Okay, 1, 2 and 2, 4 are the 2 times, but third part 1 and 4 not equivalent. Yes, without drawing we can solve this question. This will be answer and orthogonal to each other in cubic system. Direction of planes. Yes, ethics are discusses. So let's move further. What are the Miller indices of the plane that might intersect 1, 2, and 2 angstrom on the XYZ axis of the orthorhombic system? And ABC is to 2 to 1 relation. Can you show Miller indices? In previous class, I have discussed how we can find the Miller indices. Anmol, are you able to solve this question or can I discuss? This is the important question. Just like that question may be asked in exam. Hello, can I discuss?
Yes, sir.
Okay, let me discuss. So, F1 intercept on x-axis, A upon intercept on y-axis, C upon intercept on z-axis. The intercept we have already the intercept. So let's take directly. We have intercept. First put the intercept. Then by 2. Get multiply by ABC. 3, 2, and 1. These are the ABC and these are the intercept. Okay. Then convert into simplest form. So we can multiply by 2. Then multiply by 2. So 3 2 is 6. 2. Yes.
Sir.
Okay. This is simple process. Uh, Crystallographic axis ABC are above and intercept below. Converting into simplest integer. Now, next question. Which of the following are the Miller indices of the parallel body diagonal of the cube. How many body diagonal in cube? Corner to corner. Join corner to corner.
What?
So please, can you answer this question? Or can I discuss?
One, one, one will be there. Others have to draw.
So, we have to shift our origin. First take let me discuss. First take origin here and join this point and this point. This is the body diagonal and this point from the origin we move x, y and z. This is x, this is y, this is z. One, one. Similarly, I take here origin. This is the x-axis, this is the y-axis. Sorry, x, y and z. This is my x minus x-axis, minus y, z. Join this and this point. What will be the coordinate of this point?
One bar, one bar, one bar.
One bar, one bar. So first and first. Similarly, let's say consider the situation. Shift our origin on x-axis. Let's say here our origin. This is x-axis, y-axis, z-axis. Where is the origin? Join. Put it diagonal. So what what is the coordinate of this point? Minus. We have minus one and y one and z one. Okay. So this is the case. Similarly, we can move our origin on. This is the case for x and y. I can write like that. If we look at the direction. This is the case for x. For y, 1 minus 1, 1. And similarly z, 1, 1, Yes. So this and this. And for this case, you can similarly go. Yes. Now,
Yes, sir.
can you draw now? Okay, let's move further. This is clear. The angle between the direction and 1, 2, 3 and 1, -1 and 1 in cubic system. For cubic system, please calculate. Do you know formula for angle?
So it was something cos theta
Yes.
and the
H1 H2
yes, sir.
HKL K1 K2 L1 L2 multiplied by H1 square K1 square L1 square H2 square K2 square L2 square. Or we can, this is for HKL1 U1 U2 and W for cubic systems. So please now calculate. So consider with minus, if minus is there, 1 multiplied by 1 plus 2 multiplied by with minus 1 plus 3 multiplied by 1 and square 1 square 2 square 3 square 1 square minus 1 square and 1 square 2 3 1 minus 2 plus 3 4 4 9 4 14 3. So this is 2 by root 42. Please convert into beta. Theta will be
It's coming 70.
72. Okay, so answer is 72. So which of the following is are true for the crystalline solids? They have varying bond energy between the atoms. They have long range periodicity. They use a diffraction pattern. The atoms are mainly bounded by secondary bonding. I think sir already discussed.
B and C.
B and C. They have long periodic range and sharp diffraction pattern. Crystalline. If non-crystalline, don't give sharp diffraction pattern and no periodicity, long range. And another point has sharp melting point and has higher density, lower density and lower mel- melting point. Please remember. Next question. In a hexagonal system, a plane with Miller indices 1 to 3 in 3-digit conventional would be converted into the Miller Travis indices using 4 digit. Four digit. Okay. Yeah. Please convert. Do you know formula? How we can convert?
It was, I think, I is equal to negative of h plus k.
H plus K. So now answer. Yes. Negative I is equal to minus H plus K. Please verify the answer. 1, 2, 3 and minus 3. H plus K give 1 plus 2 is equal to 3. And take in minus negative sign. So minus 3. Yes. Clear? Let's move further. In a hexagonal system, Miller indices of the direction capital U, V, W in 3 digit convention could be converted into the Miller-Bravis indices using 4 digit convention. Do you know formula? If you know formula, you can easily convert. Hello, Anmol, do you know formula? Or can I write?
It was some algebra 2u plus b is equal to h, something like this, capital U. 2b plus u is equal to capital V something, and W
Okay.
remains the same, something like.
So are you able to see my slides now? U equal to
Yes,
1
sir.
by small u v w, relation between small u and capital U v w. X T. Now please calculate. You have a 5 minutes. You have capital U, V and W, minus 2, minus 1 and 1.
It is probably one bar. Yes, one bar 011.
Okay, so then clear. Let's calculate 1 by third, 2 times U. So 2 into U V W minus 2 minus V minus 1, 4, 3. So this is 1 minus 1 and this is 0. Sum of these two, W equal to 1. This 2 times minus 1 plus, so 2 plus 2 equal to 0. And so this is 0. q and v minus 2 minus 1 minus, oh, this is u sum v, small u and v, sorry, small u and v 0. This is my v plus 1. Okay, so A is answer. So please remember this converse u and v relations. What is the coordination number of the atom in case closed packed monoatomic structure? Closed
So
packed
is it in 3D?
what?
It is in 3 dimension or 2 dimension.
If not given, will be 3 dimension.
And it will be, sir, probably 12.
So answer is 12. So we can see closed packed structure. First layer is, and put one atom above on the voids. This is 1, 2, 3 in touch of this void, and put another layer. Then 4, 5, 6, 7, 8, 9. 6 is 2, and another is 10, 11, 12. So 12 atoms. Easy. First layer and second layer touch with 3 atoms, and this is the in phase same plane. This is below and this is above. 3 for the same layer. Below is 2, 2, 2. 6 air and 6 below. So 6, 3 below, 6 air and 3 below. This is 12. The atomic position of the face-centered cubicle cell are face-centered. Let's consider this one. This is position 0, 0. And other phases, let's consider this phase. What will be the position? X will be half, y will be half, and Z will be 0. Similarly, you can consider here X 0, y half, Z half, some y0 zeta. So B. Yes, B will be the answer for abscisive. Atomic position in the face-centered cubic. Okay. How many atoms in the inside the cubic cell? Clovis points, lattice points.
Both.
Four. So these are the four positions. General state. Next question: which of the following best describe the hexagonal closed bed structure? Non-primitive lattice with motif 00, non-primitive lattice with motif at 00, 1/3, 2/3, and 1/2, 1/2, and primitive lattice with motif 00, and primitive lattice with motif at 00 and 1/3, 2/3, and 1/2. So what will be the answer? I think sir discussed. So answer is B. Sorry, primitive. This is the D. You can see two atom motif that is this position 00 and 2/3, 1/3, 1/2. We also next question. FCC has centered cubic lattice has direction, the backing and plane. Close back direction along 111, close back direction along 110. Close back plane along family of plane 11, close back plane along family 110 planes. So what will be the answer? Close back direction along 110 and close back plane of direction along 115. Sir has discussed close back direction plane along from the plane, close back direction. This is plane for this is direction. Here is the explanation. The correct relation between the lattice parameter and atomic radius are in the body center set H. So answer is A, but how?
So we apply the Pythagoras theorem in the cube, then we can find that the body diagonal will
Yes,
be root 3a,
yes,
and there will be four r's. In the center, there will be a point which has 2r, and from the corners there will be 2r. So 4r is equal to root 3a.
Okay. Same like that. Let me draw a picture. This is the, let me draw bigger. So this is the three atoms. This is the center. They are touch each other. This is the cubic side. So only this is length. This is r. This is 2r. If the radius of the sphere is r, this is r. This is 4r. Okay. Latest parameter. This is root 2a and a. Again, this is 90 degree. So easily we can square plus root 2a square. Root 2 3 square. This is root 3 equal to 4r. So what is 4r divided by 2? Next question. Hexagonal cloth bag structure is described by the stacking sequence. Hexagonal
So it is AB, 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 AB.
and the ABC is not A. ABC. This is not BC, 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 BC. What will be this? This is right or wrong?
So if we change AB instead of AB, we can consider BC also. I
Yes.
think.
So this will. It's an MN. We can give one A, B, or one, two. So close breaking sequence are sphere breaking. We can see hexagonal close break, AP, and cubic CCP, APCAPs. Which of the following direction in the common plane 1, 1, 1 and 1, 2, minus 1? This will be minus 1. Let 1, 2, 1. How can we draw common direction? Are you able to draw? Please find how we can find.
I think they gave us an algebraic rule at the last of week 3, something related to Weisjon law.
Yes.
H1 U plus K1 V and L1 W is equal to 0.
So please find. This is -2 instead. So 1, 2, let's get that. First, please draw the plane. This is the HKL. Then find, and this is the law, but how we can, yes, we have to solve two equation and we can find, or we can draw the plane, and generally we can see the common two methods are there, but this is the formula. Please apply this formula. So let me take first H1KL, HKL, 1, 2, K1. What is K1? And L2, K2 -2, L1 1. So 1 plus 2. This is 2 minus 2. This is 3. And B, L1 H2, H2, L2 delta. This is 0. This is capital LW H1 K2 minus H2 K1 minus 3. So this is, we can set our origin according to this. We have to, can we convert 1 0 minus 1 for direction? We can use the symbol. So this is the equation. If you solve these equations, we can find the answer. Hello. Please draw these planes first. Let's see by graphical. Now, are you able to draw this plane? 1, 1, 1 and 1 minus 2 and 1. These are the edge wave 1, 1, 1, 1. Next one, y 1, z 1. This is 1, plus x, y 1, z 2. Let's go this is the condition to the planes. First, find the intercept on the x-axis x, y, z. So x equal to 1, y z equal to 1. So this is the plane origin. Our origin is x, y, and z. Okay, and draw 1 minus 2 and 1. This is the edge here 1 by 2 and 1 multiplied by 2. So please draw this plane, and where is the direction of this plane? Perpendicular to this plane. Join this plane 0 to this perpendicular to this plane. So this will be the direction, and common direction. We have to find the common direction. So here we can see planes that intersecting. So this is the common direction. Similarly, we have to find common direction of these planes. After drawing, we can see by graphically, and or we can solve via this method. These are the two equations here. after solving this equation, putting these value on these equations, we can find B and C answer. Hello. So these are the whole questions. Today we will discuss later. First, multiplicity. So we can find like that answer. We have already discussed 24. I think this is clear. We have already second question discussed about the Miller indices. Parallel planes at intercept distance, Miller indices, and where is the intercept on the axis. If the parallel planes are parallel, then intercept infinity. Third question: how we can find the Miller intercept if we intercept are available? Third is body triangle cube Miller indices. Fifth question: angle between. So please remember the formula of the angle cos cosine theta equal to. Then we can find easily for crystalline solids. So please remember crystalline as well as non-crystalline. That is the in hexagonal system where my indices 1, 2, 3, assume 4 digits. So I go to HK, HK, 4 hexagonal system direction and 4-digit convention. These are the relations. And coordinate system. So the coordinate numbers nearest neighbor. How many nearest neighbor or touching two atoms? This, this is the coordination number of that atom. Closed packed monoatomic structure is 12 for the 3D system. Okay. FCC. So one that is what we consider at 0, 0 and another adjacent faces. For the best following describe hexagonal closed packed structure. Primitive, that is primitive, and best set direction. So this is the answer. This is the parameter we can you find the packing fraction efficiency?
Yes, sir.
Please find question might be asked.
Body center cubic.
Body centered. What is the formula? Packing fraction.
Volume of the total number of atoms with respect to the volume of the unit cell.
Number of total atom volume. The unit cell volume. So how many atoms? Body center 2 and 1 atom area volume. If R is the radius, what is the area of the
4 by 3 pi r cube.
4 by
3 pi r cube.
unit cell volume?
8 cube.
Thank you. Please, and you have a relation. Put this relation. Find the answer. Is 4 by 3. Okay. So R cube cancel out. 64 by 3 equal to 3. 3 cancel out. F 64. 5. 3. 8. Please convert this in percentage.
68.
68%. And HCP, what is the fraction efficiency? Taking fraction efficiency. So generally such type question may be asked in the numerical section. And Miller indices also we have discussed in third question. Here, yes. In NetGet, such type question are generally asked. And efficiency type question also. Okay. And thank you. Let's close up the session. This is the last question. We will meet again Monday. Oh, sorry, Sunday, upcoming Sunday. Thank you.
Yes, sir. Thank you, sir.